So I always like to start off this. We're going to talk about perimeter first. And then talk about area. Why do we care about perimeter? When would you ever use perimeter other than answering a math question on a worksheet? Sydney.
When you're buying a house.
Okay, so there are some things with buying a house, looking at different rooms. Yes?
Like maybe the outside of your yard or something.
Okay, what would you do with the outside of the yard? If you're going out one Saturday, it's a beautiful day, and you're measuring the outside of the yard, why might you do that? Think about that, and I'm going to come back to you.
To put a fence in.
To put a fence in. So good. So people with houses care about this because I'm thinking about fences for a yard. Sydney brought up a room. Why might I measure the perimeter of a room? What would that be? What could be a reason why? Yeah.
Furniture.
Okay, furniture to see if it fits. Okay, if you're buying a sectional and your room isn't long enough and you block the doorway to get into the playroom, is that going to help? The kids probably won't care because they'll just jump over the couch and go play Xbox, but you don't want to buy furniture that's too big for a room. What else is around the outside of every room in your house? Around the walls.
Carpet.
Carpet, yes, but we're going to talk about area in a second. I'm going to come back to carpet. Yep.
Like one of those side walls thingies.
Sidewall thingies. What are they called?
Baseboard.
Baseboards. Have you ever had to clean the baseboards in your house? It's not very fun.
What's a baseboard?
Okay, so here in the classroom, there are these ugly brown plastic things. In your house, they're white, they're painted, and when you run things into them and nick them or spill something down the wall, it sits along the side, and your mom's like, what did you spill?
Oh, those never do.
Because they get really dirty really fast, they get dusty really quick, and when I want to give Reagan a chore for pretend allowance, because he doesn't do a great job of it, baseboards around the outside of the room are a great job for him to do. He uses a lot of my spray cleaner, but your baseboards are the little wood trim that go around the outside of your room, and every house I have ever been in that is finished have these little wood trims around the outside because it looks nicer, right? Otherwise, you've just got like carpet to wall, and the bottom of the walls, the bottom of the sheetrock doesn't look very nice. Does that make sense? Why else might I use perimeter? What's another thing? See if you can think of one more.
To grow crops.
Crops? How would I do something with crops?
See how big your land is, soil.
Okay. Yeah, maybe. Like if you're planting a garden, yeah. Or you want to make a raised garden, you have to go buy materials to put in a garden. Gary, what's your thought?
I know, I forgot what it's called, but like how much area your house has.
Yeah, area, your house has its square footage. We're going to talk about that with area. Yeah, we'll come back to that. So put a pin in it, we'll come back. What about all my little boards in the classroom? What do I have around the outside of the boards? Mm-hmm. There's a border, okay? Do you see how all the little teacher boards, they always have borders on them? It's because the edges of them are metal and they look ugly and the paper doesn't go all the way to the side. So we put those around there so it looks nicer for your classroom. So any sort of border question, or if you're putting lace around a pillow, borders have to do with perimeters, okay? If I have a board and I want to put this trim around the outside, it just makes it all look nicer. And I can measure how much I need by measuring the outside. So when I teach perimeter, I made up these little superhero guys. Those of you that were in small group this morning, you get to hear it twice. This is Perimeter Man. What do you notice about him? His hair, it's really big. Perimeter Man can only run around and count up the outside of the polygon that he's on, because if he tries to count what's inside, this is a shock zone. He went there once and he's never forgotten it. Next time he may not make it out alive. So Perimeter Man, his superpower is to add up the outside of a shape. Now we can use multiplication strategies because with squares we're doing the same number, but Perimeter Man adds up the outside. Okay, if I have a wonky shape, make a little Tetris box, he's going to run around and add up all the individual pieces and then count them all up together. Sorry. So sometimes he's doing a square like this. If this is a 7-inch square, do I have to do 7 plus 7 plus 7 plus 7? No. I could just do 7 times 4 and be done with it. This would be 28 inches. On these questions, it's really important if they give you units that you put it. If I make these all centimeters, my answer is going to have cm for centimeter next to it. If it's in millimeters, we're going to do millimeters. If it's feet, we're going to do feet. And after this unit, we're getting into measurement conversion, so we're going to be working with different measurements a lot. Most of the time, you're going to have squares and rectangles. On the rectangles, they don't give you all the sides. They'll tell you this is 11 feet, this is 3 feet. They'll ask you for the perimeter. A lot of kids make the mistake of adding 11 plus 3 and saying they're done, and the answer is 14. But Perimeter Man can't just run halfway there. He's got to go all the way around. So on this one here, I could do 11 plus 11 plus 3 plus 3, or I could do 11 times 2 plus 3 times 2, and then add up all the sides this way. On this one, I'll have 22 plus 6, and I would get 28 feet. Pretty easy. This is all a review from 3rd and 4th grade stuff. When we get through the first day of practicing with this, we're going to do a lot more with decimals, and then I'm going to show you how to do more complicated puzzles like this, where you're trying to figure out side lengths of really complicated shapes. I've got a whole book of puzzles where you're trying to find area of some and missing side lengths. So we're going to do that and get out of the baby boxes pretty quick. Any questions on the perimeter and why we might use them? Does it make sense? So you're buying a fence for a yard, you're putting baseboards in a house, things like that. You've got to know the perimeter, otherwise you're going to buy too little or too much. Area is a little different, and Garrison, I'm going to come back to you because you had a good thought with houses and how we use area and houses. So I'm going to come back to that. Why is area important in the real world life? Why do grown-ups care about area?
How big your house is?
Uh-huh. So area, real world stuff. houses are measured in square feet. If you buy a new house, they're going to have a price per square foot that you're going to pay, or they'll give you a range and they'll say you're going to pay between $13 a square foot and $18 a square foot depending on your upgrades. And that's how you can tell and calculate, can I buy a house that's the size I want from this person and afford it? Does that make sense? Because you don't want to get into a house halfway through and realize you're $100,000 short. So houses square feet are important because the cost of the house is an issue. The flooring is all sold in square feet. Look at the floor. Do you see what's on the ground under your desk? Each of those vinyl tiles are 1 square foot. Whoever built this school charged them money per tile that they put in the entire school. Every single tile in the whole school is 1 square foot. Now the tiles in your house, unless you live in an older house, which almost all the older houses are 12-inch tiles because they're cheaper. If you live in a newer house, you usually have 18 or 20 or 24-inch tiles because the builders charge your parents more money to put those in. And they look nicer. If you put tiny tiles in a tiny room, it looks tiny. You put big tiles in a medium room, it looks big, and it gives the illusion the room's bigger than it is. But if you go to Home Depot with your parents or Lowe's or something in the next couple of weeks, walk through the floor section and look at the carpet and the wood and everything. All the signs in Home Depot and Lowe's will tell you it's $2.89 a square foot or $4.99 a square foot. So flooring's important. Why else do we need to know square feet? Where else might you use this in real world stuff? I've used this a lot. If your job's a real estate agent or a builder, this is super important. Yep. Architecture, awesome. Yep. Interior design, very important. If an interior designer does not have a good grasp of how much it costs per square foot to do a room that they're redoing, it's going to end up costing them a lot of money, or no one's going to want to hire them. I can also tell how much paint I need for my house. If I measure all the walls, I can get a good idea of how much paint I need because the paint cans will tell you how many square feet 1 can of paint will cover. Now, if I give Reagan a paintbrush, I'm going to use a whole lot more paint and I'm going to spill a lot more paint. But if I'm trying to paint a house, I can figure out how much I need, and that way I don't buy too little or too much. Yeah.
My mom's a realtor, but she also uses like a different method. It's not square feet.
Okay, it's not just square footage, and I did real estate for 3 years, so we'll have a conversation about that. It's a factor. Okay, they look at the neighborhood, they look at how desirable the house is, how many bedrooms it has, how much square feet it has, how big the lot is. The lot size is important, so there's a lot of different things. Any questions about this? These are just area questions. If I want to put grass in my backyard, guess what they sell the grass in? They put them in big pallets, and then you buy the big squares and lay them down, unless you want to do seeds. And then guess what they have on the side of the seed containers? How many square feet that container of seeds should be able to cover. Otherwise, I'm going to have a forest in one corner of my yard and nothing in the other. Does that make sense? Okay, so area is really important. If I want to calculate what 1 square inch is, I could get a ruler and make a 1 inch square, 1 inch, 1 inch, 1 inch, 1 inch. When I say 1 square inch, that's what it really looks like. Now, your worksheets aren't going to be to scale. We're just going to draw stuff and label it inches, centimeters, feet. If I put a 8-foot by 4 foot rectangle on a worksheet, you would have a very big piece of paper to take home. Okay, we're gonna draw tiny things and signify what it is with different units. But if I wanna see what 1 square inch is, I just measure 1 inch on all sides, and the formula for area is length, length times width. If I do length times width, that gives me the area. If I have a box like this, and this is 4 inches, and this is 9 inches, I'm going to calculate that by multiplying one side by the other side, and I'm done. Area would be 4 times 9, which is equal to 36. And this is very important. I write the unit, and I write a little baby 2. Exponent of 2 means square inches, because if I look at this, 1 inch square is a 1 inch by 1 inch square. If I drew this guy to scale, I would have to draw a 9-inch line from here to here, and then a 4-inch line from here to here, and I could fill it in with 36 of those tiny squares. Does that sound time intensive? Yes. I don't want to draw 36 squares with a ruler ever. I'm going to draw a box and call one side 9 and one side 4, and it's not going to be to scale. Otherwise, we'd have to go through a lot of paper. Any questions about this? This is pretty basic stuff. The things that usually throw you guys off, and we're going to get more into this tomorrow after we practice it a bit. Sometimes they're going to give you a rectangle, and they're going to say the area is 60 inches square, and this side here is 12 inches. What is this missing length? Am I going to multiply on this one, guys? No. Because if you do 60 times 12, you're going to get a ginormous number. Would that make sense? Area is length times width. I know the area is 60, so this would be 60 equals 12 times something. I'm looking for this missing piece. When we balance equations, what do we do when we're missing something on this side? If I'm multiplying on this side, what am I doing on the other side? 12 times W equals 60. If I'm multiplying on this side, I divide, and I figure out my missing width is what? 5 inches. And we don't put a square on it. We only put the square when it's talking about the area. If we're talking about a side length, that's 5. From here to here in a straight line, that's all we're doing. Does that make sense? Sometimes it'll tell you the area is 24 centimeters squared, and this is 6 centimeters. I don't know this. And then it'll ask for perimeter. How would I find that? I'm adding another layer. How would I figure that out, Brooks?
So you know that the other side is 6 too, so you add 6 plus 6.
So you want to go ahead and put a 6 here? Sure.
And then you would add both of them together and subtract 24 minus 12.
Okay, so his method is add 6 plus 6. And then I'm going to subtract. Should I have drawn a rectangle here? Mm-hmm. Are some of you thinking that the side length is 12 right now? Because that's what I usually see. What do you have to do with that?
You have to divide the number by 2 and half to the other side.
Okay. So if the area is 24, could I do this another way? 24 equals 6 times something. What does the side length have to be? 6 times what is 24? 4. Good. So I know 4 is equal to my missing width. If it's 4 here, that means it has to be 4 here. Now could I add up all the sides and tell you the perimeter? Mm-hmm. So Brooks' method will work as well. If they're using smaller numbers for area, it's usually easier to just find this missing side length. 4 times 2 is 8. 6 times 2 is 12. And 8 plus 12 is 20. Good. So on this one, I could add 6 plus 6 plus 4 plus 4, but it's easier and faster to do double the length, double the width, add 12 plus 8, and you get 20 centimeters. So on this one, the area is 24. The perimeter is going to be 20 centimeters, and I'm done. Any questions on this? I'm going to start off with the easy ones today, but we're going to go into the more complicated shapes and do some of these more difficult ones tomorrow and practice these a whole lot. Because the boxes are easy.